Good morning, ladies. This morning we are starting the next section, which is electrostatics, and this is a physics section. And the first thing that you need to know is Coulomb's law, and according to our guidelines, it states that Coulomb's law is the magnitude of the electrostatic force exerted by 2-point charges Q1 and Q2 on each other is directly proportional to the product of the magnitudes of the charges and inversely proportional to the square of the distance between them. So this law describes two relationships. So firstly, it says that the electrostatic force, which is the force between objects that carry charges, is directly proportional to the product of the magnitude of the charges. So if I've got two charges and I increase the charges, what is going to happen to the electrostatic force? It will also increase. And then secondly, according to Coulomb's law, this electrostatic force is inversely proportional to the square of the distance between the charges. So if I take two charges and I move them closer together, so I decrease the distance between them, what is going to happen to this force? The force is going to increase. If I take the same two charges and I move them further apart from each other, so I increase this distance, what is going to happen to the force? The force is going to decrease because force and distance inversely proportional, and force and magnitude of the charges directly proportional. So if I take those two relationships and I add them together, the formula for Coulomb's law ends up looking like this. So F is electrostatic force, which is measured in newtons. Q1 and Q2, those are the charges. They must be measured in coulombs. R is the distance between the charges, and that must be in meters. And K is Coulomb's constant, which is equal to 9 times 10 to the power of 9, and this value will appear on your data sheet. Now, please don't get this confused with this formula over here, because this is something that we've done already. And this is Newton's law of universal gravitation. And here we said that this force of attraction, so in this formula, this force is a gravitational force, and it's always going to be a force of attraction. And M1 and M2 will be the masses of the two objects, and R the distance between them. If we take a look at this formula over here, this electrostatic force can either be a force of attraction or repulsion, depending on the charges that the two objects carry. So don't, as I said, don't get this formula, Coulomb's law, confused with Newton's law of universal gravitation. And to illustrate this quite nicely, we can take a look at activity 9.1, which you'll find on page 188 of your textbook. So according to this activity, they say that a hydrogen atom has one proton and one electron. And then they give us some information. So they say the charge of the electron is negative 1,6 times 10 to the power of negative 19 Coulomb. And the mass of the electron is 9,11 times 10 to the power of negative 31 kgs. The proton, now an electron and proton has the same charge, 1,6 times 10 to the power of negative 19, as you can see. The only difference is for an electron, it's a negative charge, and for a proton, it's a positive charge. Of course, they've got different masses, and you can see quite clearly here that an electron has a mass that is much smaller than the mass of a proton. And then they also give us the distance between the proton and electron, and they say it's 10 to the power of negative 10 meters, so it's already in meters, so we don't have to worry about that. Then, number 1, they ask us to calculate the gravitational force between the proton and electron. So that is Newton's law of universal gravitation. So F is equal to G, mass 1, mass 2 over r squared. The constant is 6,67 times 10 to the power of negative 11. I've filled in the masses. I have filled in the distance between them. Remember, it's r squared, so you have to square that. And the answer that I got is that, and it's a force that I've calculated, so it's Newton. Then for number 2, they ask us to calculate the electrostatic force. So this is Coulomb's law. So this is your K, Q1, Q2 over r squared. The constant is 9 times 10 to the power of 9. Now, very important, when we use this formula, we only fill in the magnitude of the charges. We don't fill in the positive or negative sign. So, although the one was a proton and the one electron, so the one is positive 1,6 times 10 to the power of negative 19, and the other one is a negative 1,6 times 10 to the power of negative 19, I don't fill the positive and negative in when I do the calculation. Because if we go back to Coulomb's law, it actually says here, force exerted by 2 point charges on each other directly proportional to the product of the magnitudes of the charges. So it's only the magnitude that we fill in, not the sign. And the distance is, of course, the same. And, oopsie, it's this one. The distance is the same. And then I get that answer over there, also Newton. Now I can go back and I can say, the one was positive, the other one was negative, and that's how I know that it is going to be a force of attraction. The gravitational force is always attraction, but the electrostatic force, it depends on the charges. Then for number 3, calculate the ratio of electrostatic force to gravitational force. So electrostatic to gravitational, I've just written down the 2 answers that I got. And I said that divided by that, and that is the answer that I got over there. It's ratio, so the newtons here and the newtons here would have cancelled out, so that's why there's no unit. And then they also ask which force is bigger, and of course I can quite clearly see here that the gravitational force is much smaller than the electrostatic force, or the electrostatic force is much greater than the gravitational force. And then lastly, the worked example on page 189. I've got 2 charges, X and Y, and they give us the charge for each one. And X carries a positive charge and Y carries a negative charge, and they are 30 millimeters apart. And of course, I know that it must be in meters, so immediately I say divided by 1,000 to convert my millimeters to meters. And then the first question, calculate the magnitude of the force. I would actually word it, calculate the magnitude of the electrostatic force that X exerts on Y. So F is K, Q1, Q2 over R squared. The constant I filled in, the charges I filled in, but not the signs once again. The distance between them converts to meters. I've remembered that I have to square it. And the answer that I get is 1,47 times 10 to the power of negative 4 Newton. Over here, I just want to remind you that charge must be in Coulomb. So yeah, it wasn't a problem because it was given as Coulomb already. But if it's given as nanocoulomb, we have to convert to Coulomb, or if it's given as microcoulomb, we have to convert to Coulomb, and that is how we do it over there. Then number 2 is the force, a force of attraction or repulsion, and explain your answer. And of course, it is going to be a force of attraction because they have opposite charges, the one's positive, the one's negative. If they had the same charges, then of course it would have been a repulsive force. And then the other thing that I just want to remind you here, this force of 1,47 times 10 to the power of negative 4 Newton, that is the force that X exerts on Y, but that would also be the force that Y exerts on X. It's also going to be 1,47 times 10 to the power of negative 4 Newton. And lastly, of course, exercise 9.1 on page 189 is what you are going to go do to practice some simple questions on Coulomb's law. Thank you, ladies.